Solving problems with quadratics. So here's a fairly typical type of problem. The hypotenuse of a right-angled triangle is 13 centimeters. There's a difference of 7 centimeters between the two shorter sides. Find their lengths. If there's a shape and there's no diagram, draw a diagram. I know my hypotenuse is 13 centimeters. Now, the two shorter sides are what we've been asked to find, and thus you will let one side, make it either the shortest or the longest, it doesn't matter. Let x be the length of the shortest side. It's important to say which side, the shortest or the longer side, just because that means I know that this one is longer, so this one is x plus 7. The difference of 7 we'd expect to see minus, but because I went for the shortest side, I've got x plus 7. If I'd let x be the longer side, this would be x minus 7. Doesn't matter either way. Now we always have to look for the piece of information that we have. Sometimes it'll be an area or a perimeter, and then you'd know that you need to give the formula for the area or the perimeter of that shape. This is different in that we don't have an area or a perimeter. What we do have is the hypotenuse. And when we have the hypotenuse, that says we're going to use Pythagoras' theorem. So choose a formula that relates a thing that you know to the two or the other parts that you don't know. Substitute in our values. 13 squared is x squared plus x plus 7 squared. Now you have to expand this binomial and gather all the like terms. And remember, this is a potential dead fairy. Do not just say, well, this is x squared plus 49. It is not. If you know that you are likely to make that error, don't skip straight to the expanded version. Do a line of working where you show that this is two separate brackets to remind yourself how to expand. So if you were doing that this way, it's 13 squared is x squared plus x squared plus 7x plus 7x plus 49. Now I put those two in a different color because they actually are not needed, because I could skip straight to 13 squared equals x squared plus, and if you know the trick for expanding a perfect square, you know that you square the first one, x squared, multiply the two terms, 7x, and I need two of those, so that's 14x, and square the second one, plus 49. But you'll see that if you're not really comfortable with that shortcut, you can just put those two lines of working in, and that will let you get this answer without the risk of messing up. Then we gather like terms. 13 squared is 2x squared plus 14x plus 49. Oh, I'm sorry, I should have squared 13 there. That would be 169. Gather all the terms to one side. So 0 equals 2x squared plus 14x. And I need 49 minus 169, and I probably didn't need a calculator there, minus 120. Don't get fooled and think you have to start factorizing a non-monic, because you always check first, is there a common factor? There is a common factor of 2. Divide both sides by 2. 0 equals x squared plus 7x minus 60. So you have written the expanded and unsimplified, sorry, the factorized but unsimplified version. You've expanded it out, gathered like terms, and now we can factorize this simplified quadratic. So we're looking for factors of negative 60 that add to give 7, 60 and 1, no, 30 and 2, no, 20 and 3, no. You'll notice I really do try, and if I can't see it immediately, I do try to make sure that I've worked my way through all the factors. 1, does 2 go in, does 3 go in, 4 goes in, 15 and 4, nope, 5 and 12, there we go. Now obviously, you don't need to work your way through all of these. You can start at, oh hang on, it's obviously 5 and 12. I'm just being methodical or taking my time. So that is 0 equals, oh now hang on a sec, which one is negative? I need a positive middle term, that means the largest one is positive, so that's a negative 5. X minus 5, x plus 12. I've factorized, I need to solve. Therefore, x minus 5 equals 0, or x plus 12 equals 0. X is 5, or x is negative 12. Negative 12 is not my answer because I have a shape here. I can't have a negative length. So your answer is not just x equals 5, because my question was find their lengths. Sorry, I'm running out of space here. Therefore, the shorter sides are 5 centimeters, and the other one was 12 centimeters. Now it's 12 centimeters because it's x plus 7. There will often be that coincidence, or that the fact that this is plus 12. If you'd worked out the longer side, you would have got x minus 12, x plus 5. I think I'd have to go in and check. But you have to remember, look, I was finding the shorter side. The shorter side turned out positive. Yes, you'll get a lot of the time your other answer as a negative here, but you must go back to what the working was for your other answer, x plus 7, 12 centimeters. You cannot just go, oh, look, there's a negative 12, it'll be 12. Don't do that. So yeah, solving problems with quadratics.